All right, this is radical exponents. This is radical exponents, exponential form and radical form. Okay? It's not Monday. It's Tuesday. Okay, you're used to seeing exponential function where we have the x raised to a fraction, and that fraction, let me see if I could zoom in on this a little bit, because we were supposed to do this last week. Okay, this is my exponential form. And this is my radical form. Okay. Now we got a couple of more terminology things. This number in our radical, that number in our radical is called the index. And we all know that this, in our radical form, is our exponent of the base. ¿Comprendes? Okay, so if we go back and look at our x to the exponent, and I'm going to use e, exponent, over our index, and I'm going to use I for index. Okay, that in radical form, here's my base, x. Here's my index. Index goes like where that radical sign is. And then I have my exponent of the base outside. Now, unfortunately, there's two ways to write this. I could put the exponent outside my radical, or I can put my exponent under the radical. Here's my base, here's my index. So either one of these is correct. What? Sure. Okay, now, if I don't have an exponent with a number, what is it? Good. So here's my exponent of 1. If I don't have an index with my radical, what is it? Now think about it. Shh. Think about it. When I have a radical with a number, what do you do? What do you do when you see this? You don't know that. What does that equal? 2, right? So what are you doing with this radical? Square root, right? It's a square root. If it's a square root, what number do you think the index is? Square root 2, right? If there's no number with if there's no number for the index, it's got to be 2. Okay? We normally don't put the 2 there. The index is the root. Okay? So this is square root. This is going to be cube roots. This is going to be cube root. This is the 4th root, the 5th root, so on and so forth. quiet. Just like we have perfect squares, we have perfect cubes, we have perfect fourths, we have perfect pies, so on and so forth. Hang on, what's that, Alana? X to the 2 over 1. Good. Exponent over index. Okay. This is our exponential form. Kayla, you got a question? Don't think so. I mean, you can, but you have to push a few buttons to do it. Okay, let's try some of this. Number 1, my base is what? -1. So we're going to put this in exponential form. So my base is -125. What's going to be my fraction? What's my exponent of -125? What's my exponent here? 1. What's my index? That's my answer. That's it. All right, so they kind of got different wording here. All right, they're calling my root or my index n. We're going to call this index. I'm not going to use random letters. I will use exponent and index. Okay. So my index is 4, and my base is a. Okay. So if I were to put this in exponential form, my base is 16. Okay. My exponent for 16 is 1. My index is going to be 4. If I wanted to put this in radical form, it's going to be the 4th root of 16 to the 1st power. I'm just doing it for teaching purposes. Okay, now we're going to go from radical form to exponential form. D exponent index. That's it. E to the 2, which is good. Five. 6, which is how about number 7? Be careful. What's my exponent for f? So I have e to the exponent over index, f to the exponent over index. Okay, let's go the other way. Okay, base 2 Index is 2. I do not have to put a number there. And the exponent is 1. I do not have to put a number there. If you want to, by all means, go ahead. I'm not sure what you said. Okay, my base is A. My exponent is 3. My index is 5. Jacob, do the next one. Yep, that's what I thought. Base is 5. Exponent is 2. My index is 5. One. Wait, that's a mean look, man. What is it? What's my base? Bases never change. This is order. How do you write it? Oh, okay. All right. So 3, then the thing, then do you write the base? And then the exponent? Okay. So number 12, you would write the 4, the radical, then the base, then the exponent. Fine. Okay, how about 13? Now we're going to, we're still doing the rational exponents. 2, radical, 9, 3. Good. Can we leave negative exponents in our answer? So what does this equal? Shh. How do we get rid of negative exponents? You just got quizzed on it. It was only 3 days ago. You flip it, right? Make it positive. Well, yeah, you can do it 32 times 32. It's at the next section we are. Okay. Yes, ma'am. It's called the radical. I do. Bueno. Okay. All right. Do you guys know how to approximate? Do you know how to put these in the calculator? Calculamators. Now, when it says to give you an approximation, you have to use your calculamators. Now, there is a way to put it in radical form in your calculator. It was way too many buttons for me to like keep it in my memory. So I always put it in exponential form. It's just easier for me. Okay? So this is in radical form. There's my base, there's my exponent, here's my index. It's easier for me to do it in exponential. What? Do what again? I haven't done it yet. Yes, it's an approximation. Is that what it comes out to be? 5 raised. I always put fractions in parentheses. 3 divided by 4. 3.34. Round your answer to the nearest hundredth. 3 raised to the exponent index. 4.33. Did I do something wrong? No. Did you put your fraction in parentheses? What'd you get? Wonderful. Now, guys, shh. Let me ask you something. In Algebra 1, did you simplify radicals?
Hold on. Now, let me ask you something. If I don't even remember what I did last night, what makes you think I remember what I did last year?
Well,
Thank you. Amen.
I just asked you if you remember how to reduce radicals. I don't even know what that means. Can I take the 5th root of 32? Can I take the square root of 32? Never mind. I'll make up a worksheet. We'll go over that. Now, you guys have your 2 worksheets, right? Worksheet A and Worksheet B, where you didn't do problems 1 through 6. Why'd you turn it on?